Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is the final exam of term 211. First question, find the derivative of this function. Well, this is an integral and we need to find its derivative. And we studied the derivative of integral when we studied the fundamental theorem of calculus in part 1 in section 5.3. So we find the derivative, and here we have a function, and here another function, and here et to the power 2 over t dt. So the derivative of the integral would be, we replace t by x squared, the first function. So x squared to the power 2 would be x to the power 4 over t, which is x squared. And we multiply by the derivative of x squared, which is 2x. Then minus, we replace t by the other function, square root of x. So we have e to the power t squared, so square root of x to the power 2 would be just x over t, which is square root of x, times the derivative of square root of x, which is 1 over 2 times square root of x. So after simplifying this, I will have 2 e to the power x to the power 4 over x, because x cancels with x squared. And here I have e to the power x square root times square root of x would be just x. So this is the final answer. Use the method of cylindrical shells to find the volume. Finding the volume was in chapter 6, and this is section 6.3, cylindrical shells. And we know if we need to find the integral about of if it is rotated about the y-axis, if the rotation is about the y-axis, then immediately we have dx here, okay? Dx would be used integral with respect to x, and we will have a b, x from a to b, and the formula is 2 pi x times f of x, which is the height. Well, let us graph the region between these two curves to let us find the intersection points. So I put x squared equals to 6x minus 2x squared because y equals y. Solving this equation, 2x squared, take it to the other side. So I will have 3x squared minus 6x equals to 0. And then I can take 3x as a common factor, and I'll have x minus 2 equals to 0. So either x is 0 or x is 2. Of course, if x is 0, then y would be 0. So this is the first intersection point. And if x is 2, 2 to the power 2 is 4. Also, if you replace x here by 2, you will get 12 minus 8, which is 4. So these are the two intersection points. 0, 0, 2, and 4. Well, x squared, we know that x squared is, this is the graph of x squared. And this is also a parabola, 6x minus 2x squared, but it will open downwards, okay? Let us find the x-intercepts of this parabola. 6x minus 2x squared. To find the x-intercepts, I put y0. So I can take 2x as a common factor. So I'll have 3 minus x equals to 0. Okay, so either 3 or 0. So 0 or 3, these are the two x-intercepts. So here would be the vertex. The coordinates of the vertex would be on this line because this line would be the axis of symmetry. So the vertex is not here, okay? To find the vertex also we can use h and k. H is negative b over 2a, and a is negative 2, and b is 6. So it's 3 over 2 we know in fact that h is 1.5 as we have seen here. So let us find k immediately. What is f of 3 over 2? So 6 times 3 over 2 minus 2 times 9 over 4. And using the calculator, this would be 9 minus 9 over 2, so it would be 4.5. So k is 4.5. So 1, 2, 3, 4, somewhere here. Okay. So this would be the graph of this parabola. It will pass by 0, 0. And then this is the region. This is the region we need to find its area. This is the region between the two parabolas. And we will use cylindrical shells. While using cylindrical shells, rotation is about the y-axis. So this is the height of the cylinder, okay? And we will have like this, okay? This is a typical cylinder. So the height is f of x, and x is the thickness of the rectangle. This is the rectangle in this case. The thickness is dx, okay? And x from where to where? From 0 to 4, because this is the intersection point. Y is from 0 to 4, sorry. X from 0 to 2, okay? This is 2, 4, so this point is 2. So x from 0 to 2. Okay, so I will write from 0 to 2, 2 pi, okay, x times f of x. Now f of x will be the height, so it is the above parabola minus the lower parabola. So the above one is this one, 6x minus 2x squared minus the other one, which is x squared, times x times dx. X is this distance. This distance is x, which is the radius of this circle, okay? The radius of the cylinder. 2 pi x is the circumference of the cylinder. This is according to section 6.3. And that's it. Just simplify and find the integral. So this is 6x minus 2x squared minus x squared will be minus 3x squared. So we will have 2 pi is a constant. I can take it out. And I will have 6x squared if I multiply this x minus 3x cubed dx. And the answer would be 2 pi times, I have 6x cubed, the integral of x squared, over 3 minus 3x to the power 4, the integral of x cubed, over 4 from 0 to 2. So I have 2 pi. Let me now replace x by 2. 6 over 3 is 2. 2 times 2 to the power 8 is 16. Okay, minus 2 to the power 4 is 16 over 4 times 3. This would be 12. So 16 minus 12. And if I replace x by 0, I will get 0 here, minus 0. So that's the answer. 16 minus 12 is 4 times 2, 8 pi. So the volume is 8 pi. Evaluate this integral. Well, if you think of this integral, I have ln x, and I don't know the integral of ln x. And in fact, I have ln x to the power 2. So this seems integration by parts. And to use integration by parts, I take u as ln x to the power 2, and I take dv as dx. If you want more about integration by parts, section 7.1 is about integration by parts. Now, du would be the derivative of this, which is 2 times ln x times the derivative of ln x, which is 1 over x. And v integral of dv, integral of dx. And now, this is, let me call it I. So the integral I equals uv, so x times ln x all square minus integral of v du. When I multiply v times du, x will be cancelled with x, and I can take 2 outside, and I'll have integral ln x dx. And to find integral ln x dx, I also use integration by parts. I take u equals ln x, and I take dv equals dx. So du would be 1 over x. Of course, there is dx here, dx, and v is equal to x. So this would be equal to x ln x all to the power 2 minus 2 times uv, so x ln x, minus integral v du. When I multiply v times du, x times 1 over x is 1, so I'll have just dx. Well, the integral of dx is x, okay? So the final answer would be x ln x to the power 2 minus 2x ln x minus 2 times minus x is plus 2x, and there is plus c. That's the integral of ln x to the power 2. Evaluate the following integral. Sine squared times cosine squared, this is section 7.2 about trigonometric integrals. And we have seen that when the power of sine there in section 7.2, when the power of sine is 2 is even and the power of cosine is even, we have to use this formula. We know that sine square x is 1 minus cosine 2x over 2, and cosine square x is 1 plus cosine 2x over 2. So this would be integral 1 minus cosine 2x over 2 times 1 plus cosine 2x over 2 times dx. And then when I multiply these two fractions, well, 1 over 4, I can take it out, and I will have 1 minus cosine times 1 plus cosine would be 1 minus cosine square 2x dx. And we know that sine square x plus cosine square x is 1 in general. So 1 minus cosine square will be sine square. So this would be 1 over 4 integral. 1 minus cosine square would be sine square, but we have 2x here. So this is equal to sine square 2x dx. Once again, we have sine square, so we need to use this formula. So this would be equal to 1 over 4 times integral sine square. Sine square would be 1 minus cosine, but here we have 2x, so here we will have 4x over 2 dx. So this would be equal to 1 over 8 times. Integral 1 is x, integral cosine is sine, but this is cosine 4x. So integral cosine 4x is sine 4x over 4, okay, plus c. So the final answer would be 1 over 8x, okay, minus 1 over 32 sine 4x plus c. Well, here I have square root of x. I have 2 plus square root of x. If you just take u equals 2 plus square root of x, then you can solve this problem using substitution. And we studied substitution in section 5.5. For more examples, please go to section 5.5. So what is the derivative of this? Derivative of 2 is 0. Derivative of square root of x is 1 over 2 square root of x. And we already have square root of x here, but I need 2, so just multiply by 2 here and 2 here. So this would be equal to, of course, there is a dx here. So dx over 2 square root of x would be du. And this 2, I'll take it outside. And I have 1 over 2 plus square root of x, which is u to the power 4. And I will write this as u to the power negative 4, and the integral of u to the power negative 4 is u to the power negative 3 over negative 3 plus c. And finally, I will replace u by 2 plus square root of x. I have negative 2 over 3, and then 1 over u cube, which is 2 plus square root of x to the power 3 plus c. I can just write it like this. Now here I have square root of 25 minus x squared. We studied in section 7.3 when we have square root of a squared minus x squared, we use the substitution x equals sine theta. So here we will use the substitution x equals 5. This is a squared, so a would be 5 sine theta. And now the idea is to change from x to theta. So I need to find dx. So dx would be 5, and derivative of sine theta is cosine theta d theta. Let me call this I again. And I'd like to find the square root of 25x squared. This would be equal to what? Square root of 25 minus x squared would be square root of x squared is 5 sine theta. So I'll have 25 minus 25 sine squared theta. And then I take 25 as a common factor, and I'll have inside the square root 1 minus sine square. If you take 25 as a common factor, I have 1 minus sine square theta, but this is cosine square theta. So the root would be 5, and the square root of cosine square is just cosine theta. So now I can change the integral I from x to theta as follows. The square root is 5 times cosine theta. X squared is 25, x is 5 sine theta, sine square theta. Dx is 5 cosine theta d theta. Well, 5 times 5 is 25, so it can be, I cancel it with the 25 here, and I'll have cosine times cosine, that's cosine square theta over sine square theta d theta. And cosine square over sine square, I can write it cotan square theta d theta. I do not know the integral of cotan square, but I know that cotan square theta plus 1 equals to cosecant square theta. So I can write this as cosecant square theta minus 1. And the integral of cosecant square is negative cotan because the derivative of cotan is negative cosecant square, and the integral of negative 1 is negative theta. So that's the answer. And now the last point is to change back from theta to x. And to do that, I know from here that sine theta is x over 5, and sine is opposite over hypotenuse. So if I have a right triangle and this is theta, the opposite is x, the hypotenuse is 5, so the adjacent would be hypotenuse square minus opposite square below the square root. Okay, square root of 25 minus x squared. So the final answer would be, what is cotan this angle? Cotan is the adjacent over opposite. So it is square root of 25 minus x squared over opposite minus. Now, what is theta? Well, sine theta is x over 5, so theta would be sine inverse x over 5 plus c, and this would be the answer of this question. Evaluate this integral. Well, I have secant square, I have tan square, tan. I know that the derivative of tan is secant square. So what if I take u as tan x? Du would be derivative of tan is secant square. Well, here there is a mistake. So this should be t. Okay. This is dt. Okay. Or everything should be as in terms of x or in t. So I will call this t. So u would be tan t, or let me then call it x. Why not? Because there is no x. So I'll call x equals tan t. And then dx would be secant square t dt. And then I can write the integral as, if this is I, secant square t dt would be dx. Tan square is x square. 3 tan 3x plus 2. And this is a rational function. So how to deal with the rational, how to find the integral, we studied in section 7.4 to use partial fractions. So I write it as, I factor the denominator, x plus 2 times x plus 1. Please, there are a lot of exercises in section 7.4 in the video about it, because now we will write it as integral of a over x plus 2 plus b over x plus 1. This is what we learned in 7.4. And to find a, to find this number here, I just here replace x by negative 2. Forget about this one. This is what we learned in 7.4. Replace x here by negative 2. So negative 2 plus 1, negative 1. 1 over negative 1 is negative 1. So this is negative 1. Okay. And now I cancel this and I replace x by negative 1. Negative 1 plus 2 is 1. 1 over 1 is 1. So I will have 1 here. And now the integral is easy. It is negative. Integral of 1 over x plus 2 is ln absolute value of x plus 2 plus integral of 1 over x plus 1 ln absolute value of x plus 1 plus c. That's the answer. You can write this ln x plus 1 over x plus 2, but this would be okay. But what is x? X is tan t, so just write it negative ln tan t plus 2 plus ln tan t plus 1. So now we have the integral in terms of t. Determine whether this integral, this is the improper integral, and we studied improper integrals in section 7.8. Determine whether the integral converges or diverges. Well, if you remember, integral, we write it like this. From 0 to infinity, ex over. Notice that this is e to the power 2x. It is in fact ex to the power 2, because now you can multiply 2 times x and get 2x. Okay, and we write it as limit t goes to infinity, and we write t here. And now we find this integral. Well, to find this integral, let me try to find it here. If I take u as ex, then du would be ex dx. And then I'll have integral ex dx would be du over ex squared, that's u squared plus 3. And this integral is integral of tan inverse, in fact 1 over square root of 3 tan inverse u over square root of 3 plus c. And this is a formula, okay, equals 1 over square root of 3 tan inverse, and u is just ex. So this is the integral. So I can write it now. Can write it here. So I have the limit. T goes to infinity of 1 over square root of 3 tan inverse e to the power x over square root of 3 from 0 to t. So this would be limit t goes to infinity of tan inverse e to the power t over square root of 3 all over square root of 3 minus, if I replace now x by 0, I have tan inverse 1 over square root of 3. Let me write it here. Over square root of 3. And when I take the t here to infinity, e to the power infinity is infinity, infinity over a number is infinity, tan inverse infinity is pi over 2. Okay, this is tan inverse infinity over square root of 3 minus tan inverse 1 over square root of 3 if you use the calculator and find tan inverse 1 over square root of 3, but be sure to be in the radian mode. So the calculator will say that the answer is pi over 6. So you can just leave it like this or write it pi over 2 minus pi over 6 is 3 over 6 minus 1 over 6, 2 over 6, which is pi over 3. So that's the final answer. Use the integral test. Okay, this is in chapter 11 now, section 11.3, if you remember the integral test. Use the integral test to determine whether this series is convergent or divergent. Verify the conditions of the test. Well, what are the conditions of the test? We have f of x. This is an, so f of x would be ln x over x cubed. And the conditions that ln x over x cubed should be positive. Of course, it is positive n from 1 to infinity. Okay. Ln 1 is 0. So for ln 1 is 0 after 1, it would be greater than or equal to 0. Positive, or you can say greater than or equal to 0. Positive. And it is continuous, of course, because ln is continuous. And this function is not continuous at 0. 0 is not here in the domain in this interval. So it's positive and continuous. And now we need to find f prime to see whether it's decreasing or not. So this is f prime. I use the quotient formula, okay? Or I can just write this as x to the power negative 3 times ln x. I can use the product formula instead of the quotient formula. Both are the same. The derivative of x to the power negative 3 is negative 3x to the power negative 3 minus 1, which is negative 4 times ln x plus x to the power negative 3 times the derivative of ln x, which is 1 over x. And this is also x to the power negative 4. So I can take x to the power negative 4 as a common factor, and I'll have negative 3 ln x plus 1. So I can write it, in fact, 1 minus 3 ln x over x to the power 4. X to the power 4 is always positive, so 1 minus 3 ln x controls the sign of f prime. Okay. Now if f is decreasing when f prime is negative, so it's decreasing when 1 minus 3 ln x is less than 0. And 1 minus 3 ln x less than 0 means 1 is less than 3 ln x, or ln x is greater than 1 over 3, so x is greater than e to the power 1 over 3. And if you use the calculator, e to the power 1 over 3 is approximately 1.4. So f is decreasing from e to the power 1 over 3 to infinity. So let me work then from 2 to infinity. I will work in the interval from 2 to infinity. I will find the integral from 2 to infinity of the function ln x, the improper integral. That's the integral test. It says if the function is positive, continuous, and decreasing, then find this uh, integral. And if this integral is convergent, then the series would be convergent. Again, this is an improper integral, so we write it like this, from 2 to t ln x over x cubed dx. And now we need to find this integral. Again, we have here ln x, so I'll use integration by parts. I have ln x over x cubed, so I can write it x to the power minus 3 times ln x. Okay, I have this integral. Let me take u as ln x, so du would be 1 over x dx, and then dv would be x to the power negative 3 dx. And the integral of x to the power negative 3 is x to the power negative 2 over negative 2. So this would be equal to limit. Uh, then we will have, let me continue. The integral would be uv, u times v. So ln x over negative 2x squared, if you take this x to the power negative 2 down, minus integral v du, v times du. Well, I have 1 over negative 2, so there is a negative 2 here. And this is x to the power negative 1. If you multiply times x to the power negative 2, you will have x to the power negative 3. So the integral would be ln x over negative 2x squared plus x to the power negative 2 over negative 2. And I have 2 here because I took the minus outside. So so over negative 4. So I can write this ln x over negative 2x squared minus 1 over 4x squared from 2 to t. If I replace x by t, I'll have ln t negative 2t square minus 1 over 4t square minus. If I replace len x by 2 now, I have len 2 over 4 times 2 negative 8. Let me write this like this, minus 1 over 4 times 4, 16. Okay. Now, len infinity is infinity because len goes like this. Infinity over t square, infinity, so this is infinity, minus something, minus something, so it would be just infinity. And no, sorry, t is infinity. If you write t infinity, then infinity over infinity, I'll have infinity over infinity. Infinity over infinity, that's something. So infinity over infinity, I have to use L'Hopital's rule. So I need to find limit len x over negative 2x square when x goes to infinity using L'Hopital's rule. Len infinity over infinity, so I use L'Hopital's rule. Derivative of len x is 1 over x. Derivative of negative 2x square is negative 4x. And if you replace x by infinity now, negative 4x square will be negative infinity. 1 over negative infinity is 0. Okay. So in fact, this limit will go to 0. And the limit would be, and this also will be 0 because t is infinity and 1 over infinity is 0. So the limit would be negative times negative would be positive. So len 2 over 8 plus 1 over 16. So the integral is convergent. So of course the integral from 1 to infinity will be convergent. If the integral is from 2 to infinity is convergent, then the integral from 1 to infinity is convergent. And this means that the series is convergent. So the series is convergent. Find the exact length of the curve. This is section 8.1, arc length. If y is given, so we use dy and let y between 0 and 1. And the arc length is given in this case by square root of 1 plus, this is dy. So if you remember, we write dx over dy to the power 2 here. More exercises are in the video about section 8.1. This is x. So I need to find dx by dy. Well, derivative of ey is ey. Notice we are finding the derivative with respect to y. And 4 is a constant. Derivative of e to the power negative y is e to the power negative y times the derivative of negative y, which is negative 1. So I can just keep this negative. This is dx by dy. Well, I need dx by dy squared. So let me write this as 1 over ey. Then dx over dy to the power 2 would be e to the power 2y over 16 minus 2 times e to the power y over 4 times 1 over e to the power y plus 1 over e to the power y square or e to the power 2y. So this is equal to, so what is dx by dy square? It would be e to the power 2y over 16. EY cancels with EY. 2 over 4 is half plus 1 over e to the power 2y. And now if I add 1 to this, I'll have e to the power 2y over 16, and 1 minus half would be positive half. And these three terms, like these three terms, can be written as e to the power y over 4 plus 1 over e to the power y all to the power 2. These three terms is a perfect square, because here, notice when we squared these two terms, we got this one. And this is exactly like this, but instead of minus, I have plus. So now I have integral of 0 from 0 to 1. Square root of 1 plus dx over dy squared would be then ey over 4 plus e to the power negative y dy. And this integral is easy. I have integral of ey is ey over 4 from 0 to 1, and integral of e to the power negative y is e to the power negative y over negative 1 or times negative 1 from 0 to 1. So I have e to the power 1 over 4 minus e to the power 0 is 1 over 4, and this is e to the power negative 1, so 1 over e, okay, minus, or you make it plus now, and e to the power 0 is 1. So the final answer would be e to the power 1 e over 4 minus 1 over e plus 1 minus 1 over 4 is 3 over 4. Find a formula for the general term an of this sequence. Sequences, this is section 11.1. Then determine whether the sequence is convergent or divergent. Okay, concentrate here. I have 1 over 3. So an would be e to some power, okay, to a fraction. What is this fraction? I have 1, 2, 3, 4. Notice when when n is 1, this is n, okay. When n is 1, I have the number 1. When n is in the here 1 over. When n is 2, I have 2 over. 3, I have 3 over. So it's clear that I have n here in the numerator. In the denominator, I have n is 1, but I have 3. N is 2, but I have 5. N is 3, I have 9. So notice that this is 3, 5, 7, 9. I am adding 2. So whenever we adding 2, this would be 2n. The denominator would be 2n. Now, is it 2n or 2n plus 1 or 2n minus 1? We have to find out. If n is 1, I have 1 here and here 2. No, I need 3. So this should be 2n plus 1. So now if you put in 1, this would be 3. If you put in 2, this would 1 over 3. This would be 2 over 4 plus 1, 5. If n is 3, 3 over 6 plus 1, 7. So this is the general term. This is an. And now to find whether the sequence is convergent or divergent, I find the limit of an when n goes to infinity. And to find this limit, I take the limit up. And when n goes to infinity, the highest power with the highest power cancel, so I'll have half. So in fact, this is e to the power half. So the limit is e to the power half, so the sequence is convergent. Find the sum of the series. We have discussed the sum of two series in section 11.2 geometric and this kind of series, telescoping sum. So to find, because in telescoping sum series we can find an like here, and then we will find the limit of an. So let us find an first. Well, an is summation ai from 1 to n. And please check section 11.2 for more exercises. So it is a1. Replace now, uh, let me write it. It is summation from 1 to n, and ai is 3 to the power 1 over I minus 3 to the power 1 over I plus 1. When I is 1, I have 3 to the power 1 minus 3 to the power half. When I is 2, I have 3 to the power half minus 3 to the power 1 over 3. When I is 3, I have 1 over 3 minus 1 over 4, and so on. And when I is n, I'll have 3 to the power 1 over n plus 1 here, and 3 to the power 1 over n here. And this is for I equals n. When I equals n minus 1, I'll have n minus 1 plus 1, so this would be n, and here 1 over n minus 1. I equals n minus 2, I'll have 3 to the power 1 over n minus 2 minus 3 to the power 1 over n minus 1. And now let us see what cancels. Well, here this cancels with this cancels with this. So this will be cancelled with whatever here, and we will have 3 at the end. And here this cancels with this, and this cancels with this. So this will be cancelled with the next one. And we can see that an is in fact equal to 3 minus 3 to the power 1 over n plus 1. And now when we find the limit when n goes to infinity, we will have 3 minus 1 over infinity is 0, 3 to the power 0 is 1. So this is the sum of this series. Okay, the sum of this series is 2. Determine whether the series is absolutely convergent or conditionally convergent or divergent. Absolutely convergent, we have talking about absolutely convergent. We have talked about it in section 11.5. Okay, if you want more exercises about it. But to find out, we usually deal with absolute value of this. Notice that sign could be positive or negative, so we cannot use here a comparison test with this series. But if let us talk about summation integral sine n over n square plus 2. Okay. Now, this series, now if I call this summation absolute value of an, and this is summation an, so absolute value of an are positive terms. All the terms are positive, so I can use comparison. So notice that sine n over n square plus 2 using the absolute value is absolute value of sine n over n square plus 2, because n square plus 2 is always positive for n greater than 1, and sine is always less than 1, as we know. So this is less than or equal to 1 over n square plus 2, and this is less than 1 over n square. And we know that summation 1 over n square is convergent P series because P equals to 2 greater than 1. So by comparison test, by the direct comparison test, summation absolute value of AN is convergent because less than convergent is convergent. So summation AN, which is this one, is absolutely convergent. Another question, this is an alternating series. Okay, if we deal with, if this is AN, uh, summation absolute value of AN, we will have summation of 2n plus 4 over 3n minus 1. This is now, if we take, you notice that if we take the limit of 2n plus 4 over 3n minus 1 when n goes to infinity, highest power with the highest power, so the answer is 2 over 3. And 2 over 3 is not 0, so by test for divergence, the series is divergent. So this series is divergent. The series summation absolute value of AN is divergent. So what about this series? Well, then also summation -1 to the power n, which is AN. Okay, just write it AN. Then summation AN is also divergent by test for divergence because limit -1 to the power n 2n plus 4 over 3n minus 1 when n goes to infinity would be plus or minus 2 over 3. So would be does not exist. So the limit does not exist. And that's why this series is divergent. Radius of convergence, interval of convergence. This is section 11.8 power series, the last section. And here we use the ratio test. So let me find the ratio test. Let me find AN plus 1 over AN. So I'll have x plus 2 to the power n plus 1 over 2 times n plus 1 plus 5 divided by 2n plus 5 over x plus 2 to the power n. There are many examples in section 11.5. I can cancel this with this. I'll have x plus 2. And here I have 2n plus 7. And this is 2n plus 5. So if I take the limit when n goes to infinity, then this will go to 2n over 2n would be 1. So it will go to absolute value of x plus 2. So summation an our series is convergent according to the ratio test if absolute value of x plus 2, which is the limit of this, is less than 1. Okay, and this means that x plus 2 is between -1 and 1. And of course, it means always immediately that the radius of convergence is 1. If I add -2 plus -1 is -3, 1 minus 2 is -1, and that's the radius of convergence. But let me try to, or let me consider the case when x is -3 and when x is -1 separately. When x is -3, I'll have -3 plus 2 to the power n. That's -1 to the power n over 2n plus 5. And it is easy to see that this series is convergent by alternating series test, because limit 1 over 2n plus 5 when n goes to infinity is 0, and 1 over 2n plus 7, which is n plus 1, is less than 1 over 2n plus 5, because 2n plus 7 is greater than 2n plus 5. This is the alternating series test. I think it's section 11.6. So it is convergence. What about when x is negative 1? Well, if x is negative 1, I'll have negative 1 plus 2, that's 1 to the power n. And 1 to the power n is 1, so I have 1 over 2n plus 5. And this series is divergent using, I can say, the alternating series test. No, sorry, using the not the direct comparison test, the limit comparison test. So an is 1 over 2n plus 5, and bn is 1 over n, okay? And summation 1 over n is the divergent harmonic series. So limit an, which is 1 over 2n plus 5, over bn, which is times n, when n goes to infinity, is 1 over 2, which is not greater than 0, and that's the condition. So by limit comparison test, summation 1 over 2n plus 5 is also divergent. So it is divergent, and then we can use, we can write the interval of convergence, -3 to -1. At -3, the series is convergent, so I close it at -3, but at -1, I leave it open. Another question, but here I have n and n, so I'll use the root test. So I'll find this one, the nth root of this. So the nth root of this would be n cancels with n and n, and I'll have absolute value of 2x minus 1 over n plus 1. Okay, and when I find the limit of absolute value of 2x minus 1 over n plus 1 when n goes to infinity, well, infinity plus 1 is infinity. Anything over infinity, infinity is 0. And 0 is always less than 1. So the series is convergent, always, okay? Always. So interval of convergence would be from negative infinity to infinity, and radius of convergent would be infinity. And this was the last question in the test. I hope you enjoyed watching the solution of this final exam.